By the trigonometric expressions. So we got two questions here. In part A, we got a fraction. So whenever we got a fraction, and simplifying means generally we want to cancel something from the top and the bottom. So bottom is only cosine square theta. That's cosine theta squared. Cosine theta times cosine theta. We can't do anything here. But on the top we got two terms. So cosine theta minus sine cube theta. Two terms. Maybe we can factor the top so that hopefully cancels with the bottom. Because we got two terms, it's like x minus x cubed. So we can copy, we can factor one sine theta out. Nothing leaves 1 minus sine cube theta. That's the three copies. One copy is out. That leaves sine squared, two copies. Okay, sine cube theta is in fact sine theta quantity cubed. Okay, all over cosine square theta. Okay, the times no cancellations yet. 1 minus sine square theta. Maybe there is a formula for this one. We know square means Pythagorean identity. Sine square theta plus cosine square theta equals 1. Okay, only square, not sine theta plus cosine theta 1. Sine squared plus cosine squared equals 1. We have 1 minus sine square. If I subtract sine square from both sides, then what do we have now? 1 minus sine square theta equals cosine square theta. So this is cosine square theta. So in the next step, sine theta times this is cosine square theta. Now two copies of cosine cancel from top and bottom. That leaves sine theta over 1 or just sine theta. Okay, that's how we can simplify. Now in part B, we got 1 minus sine square theta over a fraction. So 1 minus a fraction. So whenever we have two fractions, I mean we can make 1 as 1 over 1. To combine the fractions we have to make common denominator. Okay, so what we can do is like when you have 1 minus x over y, we can multiply this 1 by y over y, so that y would be the common denominator and y times 1 y minus x on the top. Okay, so we need to multiply 1 by 1 plus cosine theta over 1 plus cosine theta. You don't have to show that, but I'm going to show that anyways. So I'm going to rewrite this expression 1 minus sine square theta over 1 plus cosine theta. Okay, we can multiply this by the bottom 1 plus cosine over 1 plus cosine. So whenever we have two terms, is plus, we might want to put parentheses around, not really needed. Now we got the same common denominator of 1 plus cosine theta. On the top I got 1 plus cosine theta minus sine square theta. Okay, we're supposed to simplify. We are making it bigger as of now, but from two fractions, one and another, now I got only one fraction. So 1 plus means it's a quantity. Do not cancel cosine. So 1 plus cosine whole, this one is not in factor. Okay, don't cancel. On the top 1 plus cosine minus sine. If I combine, if I just look at these two only, 1 minus sine squared, look at the previous one. So when we have sine squared plus cosine squared, that's 1. And if we subtract sine squared from both sides, or we could have subtracted cosine squared had we needed, but that's not here. Then 1 minus sine squared is cosine squared. So 1 minus sine square is in fact cosine square. So I got cosine, or I can write cosine square first, doesn't matter. Cosine theta, these two combine, these two terms combine, 1 minus sine square collectively give plus cosine square theta, okay, using this Pythagorean identity, over 1 plus cosine theta. This is a quantity, okay, do not cancel anything because we have plus. But on the top, this is cosine plus cosine square, okay. This one, let me rewrite, okay. This is cosine square. That means cosine theta, 2 copies, 1 copy. To cancel something, we can factor from the top. Cosine, cosine, 1 copy of cosine theta can be factored out. Cosine theta is out, 1 plus cosine square, 2 copies, 1 copy out, 1 copy of cosine theta there, all over 1 plus cosine theta on the bottom. Now as a quantity, whole 1 plus cosine, 1 plus cosine, they cancel. That leaves just cosine theta over 1, or simply cosine theta final.